Şurayı da sileyim. Okay, so I send you the lecture notes, right? You received the notes. I will follow these notes. First, we have this preliminary stuff. I will skip some advanced calculus piece. So I suppose you all took 251, right? So you know what's partial differentiation and so on. Some of you haven't taken differential equations 254 yet, I guess, right? So you need to somehow, you know, if you have any gaps related to differential equations, you have to, you know, learn that by yourself. But I will now review some essential part of ordinary differential equations, which we will use a lot. So let me start with so-called lecture 2 of this note. Sizin sorunuz var mı başlamadan? Evet. Ya da yani öğrencileri becerebilirse sistemden olacak airdrop'ta, ama beceremezse dilekçeyle olacak. Bugün yarın belli olacak o. Okay, now so essential ordinary differential equations. Şöyle yazayım. Okay, now first order ordinary differential equations. So we always abbreviate ordinary differential equation by OED and partial differential equation by PED. So first order equations are basically two types, linear ones and nonlinear ones. Nonlinear ones, we don't have for nonlinear ones a, you know, systematic way of solution for nonlinear equations. Depending on the type of the equation, we have different methods. Linear ones always have, you know, a systematic way of solution, and we understand their theory. It is basically linear algebra and calculus, but nonlinear equations are usually very difficult to understand and solve. And usually, actually, we don't have any method, you know, which works for a big class of nonlinear equations. An equation which we know how to solve, a first order equation, is so-called separable equations, and it is the following. A first order ordinary differential equation is separable if it can be written as like this: f of y and then dy dx equals g of x. Or we write it also this way, f of y times y prime equals g of x. Okay, so why do we call this separable? Because we have y terms on one side and x terms on the other side. In other words, x and y terms are kind of separated. Okay, in this case, this is easy to solve. Why is that? This is easy to solve. How? Well, you just integrate both sides. Just consider this gadget, and let me write it this way: f of y, and then dy dx, or y prime x. Let me write it this way: y prime x, and then dx, and then here I have g of x. Integrate both of them with respect to x. Okay. Now, of course, I will need antiderivatives. So let f of y and g of x be some antiderivatives g of x. What does this mean? This means df dy is f of y, and dg divided by dx is gx, right? This is what we mean by an antiderivative. Well, if these are antiderivatives, then what are these integrals? Well, this is just, this thing is what? This thing is just, right? So f of y times y prime x is nothing but the f yx divided by dx, right? Why is that? What is the derivative of this gadget with respect to x? Well, you take first, right? I apply chain rule. This is just derivative of f with respect to y first, and then derivative of y with respect to x. But this thing is just little f of y, and this is just y prime x, right? So I can just replace this gadget by this thing. So the above integral can be written then. So this thing f of y, y prime x dx, f y x dx dx, and this is just gx dx. So what is this gadget? I take derivative of this with respect to x and then integrate it. Well, this is just f of yx, right? Plus a constant, because this means antiderivative of this expression, but antiderivative is not a single function, right? It's a actually family of functions. You find one antiderivative and add any constant to that, you get all the other antiderivatives. This is also right, just antiderivative of this gadget, which is g of x plus some other constant. Not necessarily, of course, the same constant, right? We just add another constant. Therefore, this is just f of y. Let me write it like this. Plus is equal to g of x plus, let's say, c double prime, this constant minus this constant. Okay. So this is the constant, and this is just the solution of this differential equation. Okay, so it is just the solution of this differential equation or this differential equation. Let's do some example. Efendim? Ha, şöyle mi yapayım? Okay, let's do, for example, an example like this. So solve the ODE. Let's say x times e to the power x equals y squared y prime. So this means what? This means I am looking for a function, right? Function of x so that it satisfies this equation. X times e to the power x is just y squared times its derivative, right? This is a separable equation, right? It is written like that. So let me just write it this way. X times e to the power x. And then what we do, we just integrate both sides. Okay. Well, this is just y cubed over 3 plus c. And then integral of this, well, there you have to be a little bit careful. What is the integral of this? Okay, so let's say this is u, this is dv, right? So I will have uv minus v du. So this is just uv. So x times e to the power x minus v. V is just e to the power x. And then du is just dx. So this is just x times e to the power x minus e to the power x plus another constant, let's say c prime. Therefore, y cubed over 3 is equal to x times e to the power x minus e to the power x plus, let's say, c. So actually c double prime, but where c double prime is just c minus c prime or c prime minus c. But I can just replace this constant with this, so I can just write it this way. Hatta şöyle yazabiliriz. Minus equals C. Okay. So any constant C gives me a solution of this differential equation. Okay. What about linear equations? Linear ordinary differential equations. Of course, first order. Linear means no y terms or their derivatives will be in multiplication form. So you cannot have y squared or y times y prime. Okay, each y term or derivatives should be can have only coefficients functions of x. So in general, a linear first order ordinary differential equation will be like this. First order means you have only first derivatives, and then you may have, of course, y term, but the coefficient of y cannot have any y in it, so you have only a function of x in front of y, and then maybe here you have another x term. Okay, so this is a first order linear equation. How can we solve this? Okay, so here we use so-called integrating factors. We use so-called integrating factors. What's that? It's a function so that when you multiply this equation with that function, the left-hand side becomes the derivative of some expression, a single expression. You see, this thing, if you look at this way, cannot be written as the derivative of something, right? You don't see, easily why this should be the derivative of something. In other words, you cannot just integrate this. However, you can find an expression and multiply this equation with that expression, and after multiplication, the left-hand side becomes the derivative of a single expression. Sor. Şurası tabii ki dy olarak görülebilir. Bu şey ya, dy over dx times dx. Tabii bunun çok bir anlamı yok aslında da. Ama dy gibi görebilirsin. Y prime dx'i. Ya aslında şurada yaptığım şey o. Şu. Y prime pardon, f of y times y prime şu ifadenin x'e göre türevi. Tamam mı? O yüzden bunun x'e göre integralini alırsam direkt f of y geliyor. F de nedir? F şu fonksiyon y kare. Bunun antiderivatifi y küp bölü 3 artı c. Tamam mı? Aha. Efendim? Evet, o kafa karıştırıcı bir şey. Genelde şöyle anlatırlar. İşte bu dy, dx bunlar birbirini götürüyor. Bu yani aslında anlamlı bir şey değil. Yani dx dediğiniz nedir? Dx aslında bir tane linear functional one form. Onu paydaya yazmak zaten sıkıntı da. Yani e, bu teknik açıdan kolaylık sağlıyor ama aslında hani çok anlamlı bir şey değil matematiksel olarak. Anlamı şurada yazdığımız şey. Yani peki integrating factor'ı nasıl bulabiliriz? How can we find integrating factor? Well, suppose I didn't have this gadget, so I would have just this, and then in that case, this would be a separable equation. Why is that? Because you see, then y prime is minus px times y, and then this is just 1 over y times y prime equals minus px, right? And I can just integrate this with respect to dx. So I put dx here. So this thing becomes dy. So this is just ln y equals minus px dx. Okay. Therefore, y is just, or absolute value of y is just e to the power minus px dx. I don't write plus c here. Why is that? Because this is an antiderivative, so it already has that constant term inside, right? This is not a single function, but this is the set of all antiderivatives of p. So I can just leave it like this. So y is just uh, plus or minus e to the power minus px dx. Okay. Now this thing here, this function gives me a solution of this equation, but actually this has more use. Why is that? I can just use this thing as an integrating factor for this equation. Namely, if you multiply your equation with that gadget, you see, so I will multiply my equation with this gadget, okay? So e to the power minus px dx, and then y prime plus e to the power minus px dx, px y equals e to the power minus px dx, and then qx. Şunu belki şununla çarpsak daha iyi olur. Şöyle diyeyim. Evet. Not this gadget, but this one. Now, if you look at this expression here, okay, this whole thing is just the derivative of this gadget. Y times e to the power what is that? Siz burayı görmüyorsunuz değil mi? Tamam. Şöyle yazayım. Burada işleyeceğiz. Hatta bu iyi sınıf. Aslında şeydi 106 mıydı? Yok 06 idi. 05. Orada kamera da yok. O yüzden hani e, orayı biraz türlü numaralarla aldık. Aldırayım. Şimdi bunu tekrar yazayım buraya. Denklemimiz so we multiply our equation, multiply the equation y prime plus px y equals qx with so-called mu x. It's an integrating factor to get. Şimdi şöyle olacak. Bu işte y prime mu x plus y times px mu x equals gx mu x, not gq, özür dilerim. Şu kısma bakarsanız, if you look at this part, this is nothing but the derivative of y times mu x. Why is that? Because when you take derivative of this, you get derivative of y times nu plus y times derivative of this. Now, what is the derivative of this? Because the derivative of this, so d dx of e to the power px dx, what is this? E to the power something. What is the derivative of that? Well, it is e to the power something, right? The same thing, times derivative of this gadget. But this is just the antiderivative of px, so its derivative is just px, okay? So therefore, this whole thing here, this whole thing is just the derivative of y times mu x, okay? This whole thing is just derivative of y times mu x. So my equation after multiplied with this gadget becomes this. And note that this function here, it's the exponential of integral of p, right? This function is always non-negative. It's always non-zero. Therefore, multiplying our equation with this function actually doesn't cause any loss because you can always divide with this function. Yani denklemi sıfırdan farklı bir fonksiyonla çarptığım için denklem özünde hiç değişmiyor. Çünkü tekrar onu çarptığım şeye bölebilirim. Tamam mı? Hani sıfır olan bir şeyle çarparsanız o sıkıntı. Çünkü bir daha bölemezsiniz ama sıfırdan farklı bir şeyle çarparsanız denklem değişmez. Çünkü o şeyi sağlamayacak, şunu sağlamayacak. Eksi koyarsan. Kim sordu? Ha, tamam. Yani şey eksi koyarsak sağlamayacak ya ondan. Integrating factor nedir? Öyle bir fonksiyon ki işte denklemi bununla çarptığı zaman sol taraf bir ifadenin türevi olsun. Tamam mı? O da işte bu e üzeri px dx oluyor. Peki şimdi ne yapacağız? So we have this equation. y times mu x equals 2x mu x. So we just integrate both sides. Ya da şöyle diyeyim, yani artık bir daha bunu yazmaya gerek yok. Değil mi? So integral of this expression is equal to this. Therefore, what is this gadget? So this implies that y times mu x is just integral of 2x mu x, right? Therefore, y is just 1 over mu x and then integral of 2x mu x dx. So that's the solution. Let's do one example. Şöyle. Mesela kim burada var mı? Örnek olarak. Okay, so I am given a first order linear equation. First order because the only derivative term is the first derivative. It is linear because no two y terms are in multiplication form, right? Here the coefficient of y prime is just a function of x, and here also the same thing, right? We have only y and the coefficient doesn't involve any y term in it. Actually, I can just write it this way. Okay. So px is just 2x 1 plus x squared, and 2x is just 5x to the power 4 1 plus x squared. Here, if you just choose your px to is equal to 2x, then you get you start with wrong p because your equation is not in this form, and the integrating factor you would get using this function wouldn't be the right integrating factor. Okay. So we have to find integrating factor, which is just e to the power integral of px dx. What is the integral of this? It is just logarithm of 1 plus x squared. So, right, it is e to the power integral of 2x over 1 plus x squared. This is just logarithm of 1 plus x squared. You don't need to put absolute value because 1 plus x squared is always positive. And here I have exponential function and logarithm. They are inverse of each other. Therefore, this is just 1 plus x squared. So our integrating factor is just 1 plus x squared. And then I can just use that integrating factor to find the general solution of the differential equation. Şimdi denklemimizi integrating factor'ımız ne oldu? So my equation is this. And integrating factor mu x is, it's also 1 plus x squared. So we just multiply this equation with this. So we get 1 plus x squared. Yani aslında orijinal equation'ı elde ettik değil mi? Ne diyor bize? Yani bölmeseydin zaten çözüme yakındın ama onu göremedik. Şimdi bu nedir? This is the derivative of y times 1 plus x squared. Right? So derivative of y times 1 plus x squared is just 5 times x to the power 4. So we just integrate this. Ya da integrate etmemize gerek yok değil mi? Yani türevi oysa kendisi nedir? İşte onu yazacağız. So y times 1 plus x squared is just integral of this, which is x to the power 5 plus a constant. Therefore, y is just x to the 5 plus c divided by 1 plus x squared. And c is just an arbitrary real number. So that's the solution. Tamam mı? Şimdi first order'lar böyle. Bir de second order'lar var. Onlardan da ikinci saat bahsedelim.